Hello, in this video, I will integrate a partial fraction using two examples. One with a non-repeating linear factor, and another one would be a repeated linear factor. So, integration with partial fractions. Before you integrate with partial fraction, you must know or review how to decompose a rational expression with linear factors, repeated linear factor, distinct quadratic or higher degree factor, and repeated quadratic factor. Also, you kind of need to review use substitution integration. I have videos on the partial fraction decomposition and use substitution. So if you want to watch those videos before you watch this video, go ahead. Okay, let's do the first example. Let's do a non-repeating linear partial fraction. So we got to integrate it, and you know for a fact use substitution will not work. We got to decompose this. So here, yeah, let's decompose this before. So you have 1. I don't know if you could see this. 1 over x. I don't like this color. How about this color? 1 over x times x minus 1. And this is this gets by itself. And then x minus 1 is a non-repeating linear, right? Okay, so what you're going to do is you're going to set it up like this. A over x plus b over x minus 1. So you need A and you need a B, because remember with partial fraction decomposition, the degree on the bottom must always be smaller than bigger than the top. So this is a 1. This actually has an invisible 0, so you don't need a plus B plus a constant, right? Because A is a constant already. The same thing with this. The highest power on the bottom is 1. So this has to be a constant because this has to be an invisible 0. Okay, then what you have to do is solve for A and B. And how will we do this? By multiplying all three sides by the LCD, right? So what do you think our LCD is going to be? If you said x times x minus 1, you are correct. So you're going to multiply all three sides by that. Okay, so on this side, what cancels everything? So you're just left with 1. On the right, on the middle part, only the x cancels, so you're just left with a parentheses x minus 1 plus, and then on the further right, what do you see that cancels? The x minus 1, so you're just left with bx. Okay, and then what would I do next is I wouldn't FOIL it out. What I would do is I would substitute a value for x. And I think I'm going to use, I'm going to let x equals 1 for right now. So if I plug it back in, I get 1 equals a, replace x with 1, so that's 1 minus 1 plus b times 1. Okay, so this is going to be 1 equals 1 minus 1 is 0, right? 1 minus 1 is 0, and then you have b times 1 is b. So this concludes that 1 equals to b. I'm going to box that. And then what I'm going to do is solve for a. So this time I'm going to put it back right here. And I'm going to substitute b with 1. And then I'm going to choose another x value. And I'm going to say let x equals 2. Okay, so I'm going to do it's 1 equals a. I don't know what a is. And then I'm going to replace my x value with 2. And then I'm going to replace my whoops. I'm going to replace my b value with 1, sorry. Right? I'm going to replace my b value with 1, and then I'm going to replace my x value with 2. And then 2 minus 1 is 1. 1 times 2 is 2. So a times 1 is a plus 2. Solve for a, so I'm going to subtract 2. Subtract 2. I get a equals to 1 minus 2, which is negative 1. Okay, so now I can, so this whole thing right here decomposes as negative 1 over x plus b, which is 1 positive 1. So it'd be 1 over x minus 1. And then this is times dx. Okay, so now I gotta take the integration of this. So what you could do is you could break it into 2 separate integration. So you can rewrite this as integration of negative 1 over x dx plus the integration of 1 over x minus 1 dx, right? So what I would do next is over here, what could I do? I could take a factor out of negative 1. And how do you take the integration of 1 over x? Well, it's a special one. It's basically the natural log. So it's the natural log of u, and then you still have a minus. And then over here, how do you take the integration of 1 over x minus 1? You simply you do the u substitution. So my u substitution is x minus 1. And then you take the du, which is 1 dx. So it comes out nicely. So it's going to be 1 over u. And then you have a du. So what is the integration of 1 over u? We said it's ln. So it's plus ln of u. And then don't forget the plus c. So your final answer, when you plug on this part, I should have plugged in my u already. So your final answer will be negative 1 ln of absolute value of u. For this one, our u was x, plus ln of absolute value of u, which is x minus 1 plus c. Okay, that is your final answer. Okay, go ahead and copy or pause because I'm going to clear and move on to example 2. Okay, on example 2, we have a repeated linear factor. So we have integration of x plus 2 over x minus 3 squared dx. So we got to decompose it, and we have x minus 3 is a linear factor. So this breaks down to So this breaks down to this because it's a repeated linear factor. And we got to figure out our A. Wait, is this correct? Yes, because remember how we said the power on the bottom has to be bigger than the top. So this is correct. You have the highest power is x1, and then this must be a constant. The same thing with this. Remember, you don't worry about the power. It's not the power outside the parentheses, it's the power inside the parentheses. So this has a power of 1. So you don't have to do the plus bx plus c, right? Because this has a power of 1, and then you need a constant on the top. Okay, now we got to figure out our a and b. So I'm going to multiply all three sides by the LCD. And what do you think our LCD is going to be? It is going to be, if you said x minus 3 squared, that is correct. So you're going to multiply all three sides by x minus 3 squared. Okay, so over here, what do you see that cancels? The x minus 3 squared, so you're just left with x plus 2. Over here, what do you see that cancels? The x minus 3, right? The x minus 3, so you're just left with uh, a parentheses x minus 3 plus over here, the x minus 3 cancels, so you're just left with just b. Okay. Then what I'm going to do is I'm going to substitute an x value. So I'm going to substitute x value 3, let x equals 3. So this is going to be 3 plus 2, and then 3 minus 3 plus b. 3 minus 3 is 0, times it by a, that's 0. 3 plus 2 is 5. 5 equals b. Okay, I'm going to kind of box it because I'm going to have to use it again. And then I found my b, so now what I'm going to do next is plug in my b value again, and then plug in another x value. So I'm going to use this equation. And this time I'm going to let x equals to 4, and then set b for 5. So it's going to be 4 plus 2, and then set x for 4. So that's 4 minus 3 plus my b value, which is 5. 4 minus 3 is 1, plus 5. 4 plus 2 is 6. A times 1 is a, plus 5. Solve for a, so you're going to subtract 5, you get a equals to 6 minus 5 is 1. Okay, so now I know my a, now I know my b. So this breaks down to, so this whole thing decomposes to, a is 1, so it's going to be 1 over x minus 3 plus my b value, which is 5 over x minus 3 squared times it by dx. Okay, I'm going to erase this because I need more space. So go ahead and pause if you need to figure, I got to erase. Okay, so what I would do is maybe I could break it down into two different integration, right? So on this one right here, I would integrate it using u substitution. So I'm going to set u as x minus 3, and then du would be the derivative of x is 1, the derivative of negative 3 is 0, and then don't forget your dx. So it comes out nicely. This is going to be 1 over u, and then you're going to replace the 1 dx with du. And we know what the integration of 1 over u is. It's the ln. So it's going to be ln of absolute value of u, which we can just say x minus 3. Okay, now let's do this part. How do we take the integration of 5 over x minus 3 squared dx? Well, 5 is a constant, so that's whenever I have a constant, I put it outside the integration. So I'm going to put 5. This 5 now just becomes an invisible 1, and then you have x minus 3 squared dx. And I'm going to have to definitely use u substitution, and my u substitution will be x minus 3. Not just x, but x minus 3. And then du would be 1 dx, right? Good. We don't need to cancel anything. It comes out nicely. So it's going to be integration of 5. This is 5, and then it's 1 over u squared, because remember our u is x minus 3, not just x. And then I'm going to replace 1 dx with du. Okay, and if you want, what's the integration of 1 over u squared is not the ln, because this is a power of 2. So what you can do is rewrite 1 over u squared as a negative power, so that you can rewrite that as u to the negative 2. And then what is the integration of u to the negative 2? It would be negative 2 plus 1. That's u to the negative 1 over negative 1, which is negative 1 over u. And then times that by 5. So that's negative 5 over u. Okay. And so our final answer, so this is going to be minus 5 over u, which we said on this part our u was x minus 3. And then plus d. So your final answer is ln absolute value of x minus 3 minus 5 over x minus 3 plus d. Okay. Okay, so that I'm only doing 2 examples. The next example would be a distinct quadratic higher degree factor. So that'll be another video. I will stop here.